Let's continue now with the vectors in R. So previously, in the previous video, we talked about we call them single scalars, but in fact they are vectors of length 1. But now let's really talk about vectors. So a vector is an aggregate of several values that they should be of the same type. So this is a valid vector of numbers. Don't forget that these are doubles in reality. And this is a valid vector of characters. So the function C from the word concatenate is used to create vectors. So for example, the A here is the vector comprises three numbers, 1 to 3, and the vector B here is a vector comprises these three strings, which are of type character. So the length of a vector is just the number of elements that it contains, the same for length of B. Probably I didn't draw this, so now length of B is 3. And the important thing about vectors is that they should have the same type of all elements. So for example, this one is not a valid vector, but it's possible that R will not complain, but it will try to convert one type to the other. But let's see what will happen, because I'm not sure if it will report an error or if it will just try to convert the 2 and 3 to strings. Yes, indeed, we see that since this is a character, it has a priority over the numbers, and 2 and 3 became characters. So after all, it's not really allowed to have multiple types within a vector. And so if we have another one, a bit more complicated. Let's see what B will be now. So B is true, A1, everything became character. So this true now is not really the true value, the logical true, but it's a character, the word true. Okay. So in any case, we should be careful when we create a vector. Now C is really the most primitive method to create such a vector. There are other ways also. So a classical method to generate a vector of integers this time is the range operator, so this one. So this specifies that I want a vector of integers, and it will be all integer numbers between 1 and 10, included both 1 and 10. So this is the vector. And if we assign that to a variable, and then we ask class A, it will be integer. So this one is, at least as a class, is different than this one. Because this is a class numeric. So this integer, this is double, but in reality actually doesn't really make so much difference. Practice is not so different. Okay, so this operator here is another way to generate vectors of integers, and it's possible to do it in reverse order also. So 10 to 1, it will be all integers from 10 to 1 in reverse order. Now it's possible to use also functions that return vectors, and there are several of them in R. So here functions that return vectors. Classical one again is the function sec, and if I ask for some help here, okay, let's ask for some help for sec, just to demonstrate also the help far. Okay, so there are two ways to use sec. One is specifying from, to, and the step, or otherwise the length. So for example, sec 1 to 10 by step 2, it will be the numbers 1, 3, 5, 7, 9, and it will stop there, because the next number would be 11 and it's greater than 10. So another thing to remember here is that since I call this function, this from is the first number, then the to is the second number, and then the by is the third number. By is a step here. Now if I want to use the length dot out, which is how many elements I want to have here, I must say that length out equals to, if I will say here 10, then it will try to put 10 numbers between this, and this is rather obvious. But if I will put 11, it will make smaller spaces between them. So it has to start from this number, and also it should stop at this number. Okay, so this sec, and another type of functions that we will use all the time and return vectors is the random functions. So if I want, for example, a random uniform number, all these functions start with R from the word random, random uniform. I need 10 values, and this uniform numbers should be, for example, from 10 to 20, and these are 10 is 10 random uniformly distributed random numbers between 10 and 20. If I want to ask for 100 numbers distributed randomly uniformly from 10 to 20, I will have to do this thing here. So in factor, because you see that I'm waiting for some time here, R is not slow, this should be immediate, but since I'm working with the browser version of R, so the RStudio server, and this machine is located in another PC, perhaps the internet connection is a bit slow, and that's why I have to wait between the commands. Okay, these are 100 random numbers distributed uniformly between 10 and 20. Alright, and if I want to get 50 numbers distributed following the Gaussian distribution, I have to use rnorm 50 numbers that have mean 0 and standard deviation of 10, and these are the numbers. So the mean is 0, which means that if I will find the average here, it will be approximately or close to 0, and the standard deviation is 10, showing how much these numbers deviate actually from the mean, and there are 50 of them. Now, since I have a vector, you see the outcome here is like that. So the number here, this one in the brackets, shows the index of the first of the element next to them. So this is the first element, this is the 6th element, this is the 46th element, 47, 48, 49, 50. So there are 50 numbers here. And so this is indicative also of the fact that this A here, where is it? Yeah, this A here is in fact a vector with one element. Okay, so the most usual ways to generate vectors is again the range operator, which is this one. Okay, let's put them in comment. This is the comment symbol. The range operator, the sec function, I will call here random functions, and yeah, there are several other functions that create in fact vectors. Another very widely used function is a sample function. So I can say that I want to sample from the vector true false 100 values with replacement. So here I say I want from this vector, which has 2 elements, to sample 100 values, of course with replacement. So the result will be something like that: false, false, true, blah blah blah. So 100 random values from here. So sampling is another method to get random values. For example, if I want to sample 100 random values from 1 to 1000, I can do something like that, and I want these numbers to be integers. So from 1 to 1000 I want to sample 100 numbers, perhaps with replacement. So these are 100 random integers from 1 to 1000, and of course they are uniformly distributed. Okay, now these are basic things how to create some vectors. Let's go to the operations of vectors now. So if I have the vector 1, 2, 3 and the vector 3, 4, 5, I can, and I do the summation of them, then I have element-wise summation. So this one will be summed with this 3, 2 with 4, and 3 with 5. And it will create another vector that will have a length 3. It will be the 4, 6, 8. So 1 plus 3 is 4, 2 plus 4 is 6, and 3 plus 5 is 8. So I have this element-wise operation. Now if the same is true for multiplication, again element-wise, 1 multiplied by 3 is 3, 2 multiplied by 4 is 8, and 3 multiplied by 5 is 15. The same is true for division. And the same is true actually for all operations. Let's wait for a while, the connection is a bit slow. Yeah, and the same is true also for the power. So 1 to the power of 3 is 1, 2 to the power of 4 is 16, and 3 to the power of 5 is 243. And so on and so forth. All operations are element-wise. Now, if the two vectors have the same number of elements, then it's very simple to understand what's happening. The first is doing something with the first of the other vector, the second with the second, the third with the third, the fourth with the fourth if exists, and so on. Now, if the vectors do not have the same length, the situation is a little bit different. So let's take the vector 1, 2, 3 and let's sum it with the vector 1, 2. What will happen here is that the smaller one, which is this one, will make a cyclical rotation on the first one. So 1 will be summed with 1, it will give 2, 2 with 2 it will give 4, and 3 will go again with the first element, will be 1, which will give 4 again. So it reported a warning message, but actually it did the operation. It's 2, 4, 4. And the warning message says that the longer object length is not a multiple of shorter object length, because this is 2, this is 3, and it's not a multiple of 2. But if I could have another element here, 4, then it could go normally as a rotation. So 1 with 1, 2 with 2, 3 with 1, and 4 with 2. 2, 4, 4, 6. Now we can understand, based on what we said before, that in R there are no scalars, that this operation will, in fact, this is a vector of length 1. So the rotation is trivial here, because what it means is that 1 will be multiplied with 2, 2 will be multiplied by 2, 3 by 2, 4 by 2. So the result will be a vector with 10 elements, but each one will be a multiple of the first vector by 2. So if I could tell you that I would like to get all integers between 0 and 100, but only the even ones, then you can do something like 0 to 50 multiplied by 2. So this element-wise way of operation is very comfortable in R. We must get used to that a little bit, but it's a very comfortable way. And in fact, it's much faster than performing for loops. One, for example, could perform a for loop here and create a new vector, but this is very slow. So in exercises and in exams, I would really strongly suggest to use this way of operations, which is called vector arithmetics, than performing for loops. I haven't showed yet for loops, but later on, when I will show some extra functions with vectors, we could see that. And in fact, we can see it right now. So we have this function, as I said before, that what it does is doing concatenation of elements in a vector. So this thing is concatenating 1 and 2 in a vector that is this one. But we can do the following. Whatever we will put here, it will be concatenating in a vector. So this one, for example, eventually it will be the concatenation of 1, 2 with the vector 1, 2, and this will be the 1, 2, 1, 2 vector. 1, 2, 1, 2 vector. Okay, this is very good now because it allows us to expand vectors, to extend them, to make them longer. So for example, if I have the vector this one, I can do and this one will be the vector 1, 2. So what I say here is that I get the A vector, and on that I add the value 2. So eventually A is 1, A comma 2, it will be the 1, 2 vector. Now this is something that is not needed here. I could have it like that. It's exactly the same. I could even start from an empty vector here and say that A is whatever it is with 2. Now A will just be trivially a vector with a single element, which will be just 2. Okay, I didn't execute this command, that's why it's a mistake. So let's see how it is. Okay. Now we can put all this in a for loop. I haven't shown for loops yet, but I can do it now. So the syntax of a for loop is the following: for a variable I that will take values within a vector. So remember that this is a vector here, which means that I will successively take all the values specified in this vector, and this vector is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do something, and I can say that A is empty the beginning, and then A equals whatever it was, comma, I multiply it by 2. So then with this way I can generate the 2, 4, 6, 8, 10, all the values, the even values up to 20. Okay, of course this is a way to generate this vector, but in fact this is a very slow way. It's slow because of the for loop and slow because of the appending here. So here I append this value to the A vector, and this is a very slow process. So this is a very bad way actually to write this thing, because they are exactly equivalent, or even this thing. These two are much faster than this one, especially the first one is much faster. So whenever you can perform vector arithmetics, do it. Don't do for loops. Avoid for loops. The for loop should be your last solution. If you can do vector arithmetics, just do that. So if I ask you, for example, to find all the powers of 2 up to the 2 to the 10th, it's very easy to think the following. Okay, you can even start from 0. So this will be powers, and 2 to the power of this will be the result that we want. 1, which is 2 to the 0, 2, which is 2 to the first, 2 to the square, 2 to the cube, 2 to the 4, 2 to the 5, to 6, 7, 8, 9, and of course 2 to the 10 is 1024. and yeah, this also is true the reverse order if I just need that for some reason. Yeah, don't forget that actually this is exactly equivalent to this thing. So what's happening, because this is shorter than this vector is shorter than this vector, is this rotation. So this has one value, so the first value of this vector with the first value of this vector is performing this operation. The first value again of this vector with the second value of this vector, this operation, and so on. So this is exactly equivalent to this one. It expands like that, in other words. Okay, probably didn't push. Yeah, I have 11 values here, not I didn't put all of them. That's how it's correct. Okay, now another useful functions to create vectors that I didn't that I forgot previously is the repeat function. So the repeat one is quite convenient function sometimes, and how it operates is the following way. I want to repeat the number 10, for example, 5 times. So this is 10, 10, 10, 10, 10, 5 times. Now here as the thing that I want to repeat, I can even have a vector, and now I want this to repeat 5 times. It will be 10, 2, 10, 2, 10, 2, 5 times. Okay, but it's possible that I want to say that I want to repeat this vector 5 times, but not in this order, not 10, 2, 10, 2, 10, 2, like we see here, but 10, 10, 10, 10, 10, 2, 2, 2, 2, 2. And then I must say here that I want each one to be repeated 5 times. If I want the repeats to be different for each element, so if I have this one and I want to repeat the first element here 5 times, the second element here 10 times, and the third element here 100 times, or 100 is too much, let's put 3, then I must specify it this way. Now it will be again element wise, that this one will be repeated 5 times, this one 10 times, and this 3 times. So I will get this vector 10, 10, 10, 10, 10, 2, 2, 2, 2, 2, 10 times, and 3 times the 3. Another way to create vectors, so yeah, what I said here is that vectors are dynamic in the sense that we don't need to pre-specify their size. We can create an empty vector and then append elements on them. I haven't shown the subsetting yet, but I will show that in another video, in the next video. What I want to mention though is that if I know from the beginning, beforehand, how many elements a vector will have, then even if eventually I will have to do a loop, I should avoid appending elements to a vector because it's slow. So a better way to fill in this vector with elements would be the following. Since I know that this element should have, this vector should have 10 elements, I should say I should use a function vector. I can say then that this vector is a numeric vector and its length is 10. So I created this vector and then I can say here that for I equals 1 to 10, and now I can use the index of the I haven't talked about indexes yet, equals to I multiplied by 2. So I haven't talked yet about this, but I will talk in the next video when I will do the subsetting. But this is the ith element of the vector. So this is much faster than appending. Appending elements to a vector is very, very slow. Okay, that's for the moment. Again, what you should remember is, whenever possible, do vector arithmetics directly on the vectors. So something like that, 1 to 3 plus 1 to 3, not in a loop. Avoid loops, avoid repetitive procedures, do vector arithmetics. R allows that and it's very fast. Okay, thanks a lot.